Hello and welcome back to the channel. In this video, we are going to cover chapter 2 of the Principles and Practices of Commercial Construction textbook. So as you already know, there are 16 chapters. So this is video 2 of 16. And this chapter is pretty long. So what topics are covered here? Let's see. So we're going to talk about the site evaluation, feasibility evaluation and land development, then preliminary investigation, nature of soil, subsurface sampling, surface testing, secondary investigation, surveying the site, foundation layout, and benchmarks and deep excavation. So let's dive deeper. So you know that when you just get the project, the site needs to be evaluated. So the successful completion of any construction project can be considered as the transformation of an idea, a need, or a vision into something of value and permanence. So a feasibility evaluation is done prior to the physical evaluation. And this sequencing is necessary since there would be no need to do a physical site evaluation if the use of the site were not compatible with its features, location, and zoning limitations. So let's talk a little bit about the feasibility evaluation and land development. So most lands available for development come under the authority of a local or regional planning board that sets procedures and fees for all development within the area under its jurisdiction. So, in planning acts can be instituted by federal, state, local officials, and the size of the area controlled by the planning acts depends on which level of government is involved. So the purpose of Planning Act is to provide a set of guidelines in the form of zoning bylaws to control the development that occurs within the area controlled by the particular Planning Act. So if an owner has a particular occupancy requirement, the location of the building will be dictated by the local planning and development board. On the other hand, if the owner has a particular site for development, the type of building and occupancy will be regulated by the zoning bylaws within the area. So, and you know that to obtain the required permits, complete construction drawings must be submitted to the building inspection department for evaluation and approval. Once the approval has been obtained, a building permit is issued to the site and construction can commence. So when we talk about the construction team, so we already spoke about that in chapter 1, but two important things must be in place before the project begins. So the owner must have appropriate funds to fund the project and a suitable site. So and once everything is in place, the owner selects an architectural firm to be responsible for the design of the project. So the amount of testing done on the site depends on a number of conditions: the size and complexity of the structure, the type of soil, and proximity of the proposed structure to existing buildings, and the level of groundwater table. So those are one of the a few more important items that must be considered before that. So as you already know, many projects exceed construction designers' budgets and completion dates because of unforeseen problems during the excavation and construction of the foundation. So the site evaluation can be considered in two phases: primary investigation and secondary investigation. And it's not because one is more important than the other, it's just the sequence. So let's take a look at each of these. Preliminary investigation or primary investigation is usually done in two stages: surface evaluation and subsurface investigation. So, subsurface investigation consists of the evaluation of near-surface soils to establish initial criteria for drainage and site preparation features, and to gain insight as to probable foundation requirements of the proposed structure. So, the methods used in obtaining near-surface and subsurface soil samples vary significantly depending on the complexity and size of the proposed structure and the site features, including vegetation. So for the surface evaluation, the topography of the site is of prime concern to both the designer and the builder. From the designer's point of view, the structure must be designed to complement the site, and the builder must be aware of the conditions under which construction must proceed. So as far as subsurface investigation, large buildings impose substantial loads on their foundation and depend on soil of good bearing capacity. So, and we will take a look at different types of soil as well. So, you know that for engineers and architects, soil denotes all the fragmented material found in the earth crust. So, and we will take a look at the soil types, and they are determined by the particle size. So let's see, we have boulders, and that's 12-inch or larger in diameter; cobbles larger than 3-inch, smaller than 12-inch; then gravel, smaller than 3-inch in diameter and larger than number 4 sieve; sand, particles smaller than number 4 sieve and larger than number 200 sieve; silts, particles smaller than 0.2 millimeters and larger than uh, larger than 1/1000th of the millimeter in diameter; and clays are particles smaller than the silts. So, and there are relative bearing strength of soil. You already know. Please refer back to the textbook. There is a chart that you can see, and you can see cohesive soils, rock, and miscellaneous soils here, and you can see the bearing capacity, the bearing strength of soil. So cohesionless soils include sand and gravel, and those soils have particles with little to no tendency to stick together. Cohesive soils may include dense silt, medium dense silt, hard clay, stiff clay, firm clay, and soft clay. So the mixture of sand, gravel, and clay, with the clay acting on as a weak cement to hold the particles together. That's the miscellaneous soil, and they include glacial, till, and conglomerate. Rock is subdivided into its geologic category, typically as metamorphic or sedimentary. One problem caused by soil and building operations related to backfilling around foundation walls and service trenches. Subsurface soil in its natural state is compacted by the weight of overlying soil and, in many instances, has been consolidated by geologic forces such as pressures due to glaciers. What is important to remember here: to control the amount of settlement, it's recommended that the fill materials be placed in layers, not more than 6 inches thick at or near its optimum moisture content to achieve its maximum density. So let's talk about the frost penetration. Buildings that are located in cold climates or are subjected to artificially produced temperatures, such as ice arenas, cold storage plants, and ice plants, can experience differential movements in their foundations as a result of frost action. So in many instances, when the ground freezes, there are no visible changes in the soil. However, fine-grained soil such as clay, sands, and silts are susceptible to volume changes due to the expansion of the soil moisture as it freezes. So the resultant increase in the volume of the soil at the frost line and above can cause unwanted pressure on floor slabs and building foundations. So in a building site investigation, it's possible of ice lenses forming around foundations or under concrete floor slabs must not be overlooked. So the three factors that contribute to frost heaving are freezing plain in the soil, a fine-grained soil through which moisture can move, and a supply of water. So let's move to the subsurface sampling. So subsurface exploration is of prime importance to designers in gathering information for the design of the building foundations. So please refer to the textbook. There are nice images and you can see different types of equipment here, such as truck-mounted drill rig. Then you can see the split spoon sampler, and you can see Shelby tubes used for obtaining soil samples from the test borehole. So please review those. And also, there are other methods that are available for use in the evaluation of subsurface conditions. And you can just take a look and you can see there's test pits, wash borings, rock drillings, and so on. So, and there are actually instruments showing how to do that, like a crawl mounted drill rig and others. So please refer to that. So also, there are two common types of geophysical instruments that are used to shallow 100 feet subsurface investigation and exploration. Those are refraction seismographs and earth electrical resistivity units. Please again refer to the textbook. You can see the schematic diagram of seismic wave refraction principle and so on. So, and the seismic refraction theory is based on the fact that shock waves travel at particular and well-defined velocities through materials of various densities. So the denser the material, the greater the speed. So please take a look at this nice diagram here. So as far as the surface testing is necessary when excavations are made in native or field soils. And soils are removed and backfilled with select materials, and also fill is placed on the site. So when we talk about the penetration tests, they provide a fast and easy way of gaining an indication of the bearing capacity of soils. Two approaches have been developed, the static penetration test and the dynamic penetration test. Both methods measure the resistance of the soil to a device commonly known as penetrometer, which is pushed or driven into the soil as in a predetermined manner. So take a look. There are different types of penetrometers here. There are pictures of proving ring penetrometer, and then there is also other devices. So shear tests. Let's talk about that. The ability of a cohesive soil to support load is related to its shear strength. So where cohesive soils are supporting building foundations, an indication of the strength of these soils can be determined by a quick test known as the shear test. And you can see there is a handheld vane shear tester kit here. So It may be used on the surface, in excavations, or with extension rods down a borehole. It consists of a four-bladed vane connected by a rod to a torsion head containing a helical spring. There are also the handheld shear testers shown here, so please take a look. So compaction testing. Areas of the building site, such as building foundations, parking areas, roadways, and sidewalks, need a proper base to support their respective loads without experiencing excessive settlements. So, and that's why the compaction testing is required. And the testing process begins by obtaining soil samples of the various soils on the site that are to be compacted. And in the lab, those samples undergo a standard lab test known as a Proctor test, developed by R. Proctor in the 1930s. So there is a compaction curve for soil shown here in the diagram. You can take a look at that, and you can also take a look at this curve known as zero air voids or saturation curve. And there is a formula for that. So please just make yourself familiar with that, because this is important and we will need that a little later in this course. So moisture tests. There are a number of reasons for taking moisture tests on soils during construction and several methods of doing so. One method involves the use of a tester that operates on the principle of a calcium carbide reagent being introduced into the free moisture in the sample. So there is a nice chart showing how to use a moisture density relationship or Proctor curve. So please take a look at that to see how you can measure the moisture content. So as far as the moisture density tests, to achieve uniformity of the barren soils, density and water content must be carefully monitored during the backfilling operation. So, in the proper compaction of the base material is very important under structural components such as slabs on grade and pavements that rely on the stability of the underlying supporting material for their strength and performance. So here you can also see the nuclear moisture density tester used in evaluating the moisture content and the density of compacted materials. So take a look at that. Also, there is a direct transmission method, and you can see that how that is done. So there are different types, and different jurisdictions require different types of testing. So let's move to the secondary investigation. And again, I mentioned that already, but that is the chronological sequence. It's not that it's less important than the primary investigation. So the secondary investigation can be as extensive as the primary and is usually done in response to adverse findings in the primary investigation. So access to the site. It's often advantageous to give thought and study to the most practical and economical routes by which equipment and materials are to be moved to the job site. So you need to always remember about that, and it may be necessary to build a private road to actually deliver everything to the site. Also, availability of services. So is there electrical power at the job site? Is there water? Is there gas? Is there something that you need? So you need to really just do the proper due diligence before commencing the construction. So site safety and local building bylaws. So the typical requirements in the construction plan include the following: a plan of the construction operation, including the extent and length of time of street closures, if that is the urban site, and enclosed building site with proper fencing and appropriate overhead protection for pedestrian traffic. Also, proper barricades and shoring around all excavations, and scaffolding to be designed, erected, and approved by qualified individuals. And I'm sure you've seen those sites everywhere in the cities. So you need to remember that such government agencies as OSHA or Occupational Safety and Health Administration, as well as the state and provincial bodies such as the Workmen's Compensation Board, provide guidelines for all aspects of safety on the construction site. So it's always good to review their guidelines, and I highly recommend to go to their website and just check the most up-to-date guidelines and requirements. So typical safety concerns on the building site include the following. You need to have the first aid kits. All supervisor personnel must be trained. Then all shoring used for open trenches must be approved by certified personnel, known as a competent person under OSHA guidelines. Then all working openings in floors and roofs must be enclosed with proper barriers. All ladders and stairs must be fitted with appropriate handrails to secure them to the walls. All hoisting equipment, such as tower cranes and construction elevators, must meet local safety standards, and they need to be maintained on a regular basis as well. So all sheathing materials must be properly stored and secured to ensure they do not become airborne during windy weather. Then all individuals working on the site must be equipped with hard hats, safety glasses, safety boots, lifting harnesses, and gloves, or PPE, personal protective equipment. Then appropriate respirators and a fresh air supply must be provided for crews working in enclosed spaces. So also local labor supply. So if you work on a project in a remote area, you need to check the availability of skilled and unskilled labor, and just understand what you can rely on. And also please consider the local weather conditions, because that actually plays an important role when you plan your construction job. So if that area is subject to a great deal of rain, or it's unusually dry, or just like there's a lot of snow, a lot of cold days, a lot of heat. So please consider those things and aspects when you plan the construction. So there are a few beautiful layouts here. Please check them out, because it's important to understand how actually that is done. So when you survey the site, the various surveying activities on the building site must be handled appropriately, depending on licensing requirement for surveying in the locale of the project. So in most location, any definition or location of the boundaries of a site, the establishment of benchmarks, the location of easements, any function requirement, the development of legal description of the survey requires the services of a licensed professional land surveyor. So when we talk about the boundary survey, that establishes the location of all property lines that bound or confine the site. Then topographic survey, or topo, that establishes the elevations of the existing site. And please refer to all the images here in the textbook. And also there is laser level. That's a direct development of space age technology. So that's, I'm sure you've seen that a lot in the cities. And that is just to understand the level, because that produces a controlled beam of red light, and that is made to measure the horizontal level or vertical alignment. So, and again, there are a few schematic images here, how to do the grade alignment, and a few pictures, how actually that the laser level looks like. So please refer to that, because that's actually important to see how it's done. So layout before excavation. So the boundaries on the lot on which a building is to be constructed should be established by markers called monuments set by a professional land surveyor. So that needs to be actually done before the construction begins. So let's take a look at um, the layout before excavation. So what you need to remember here is the better boards. So what is that? Those are horizontal bars fastened to posts, which are set up which are set up in pairs around the important points in the building. So, and the basic purpose of such staking is to enable workers to locate better boards correctly. So they must be set far enough back from the stakes to ensure that excavating will not disturb them. So please review that. That is important to understand how it's placed, why it's placed, and actually how the excavation is performed after that. So when we talk about the foundation layout, upon completion of the site investigation and design of the foundation, such as better boards and so on, actual site work can begin. In many instances, preliminary excavation must be done on the site before the actual layout of the building foundations begin. So here again, just take a look at the typical foundation plan. Here it's both in metric units and the imperial units. You can take a look at different variations of that. So parking layout, just how that is done. Then please review those images as far as locating points from better board lines. So that is important to understand how to establish a foundation corner position from better board lines. And there's a beautiful image following the paragraph. So also, there is a layout for footing forms. There are several methods for establishing the outside line of exterior footing forms. So for simplicity, if the footings are not large, the projection of the footing beyond the outside wall can be measured easily. So, and you can see the diagram of the location for the footing corner stake position. So please review that. Also, what is important here is the leveling of footing forms as well. So the first stake driven to a known elevation is now used as a reference point to level the remainder of the footing stakes or the top of the footing forms. So set up the instrument in a convenient location within the perimeter of the building, then take a backside on the rod held on the first stake and tighten the target in position. And now have the rod held alongside the next stake to be leveled and have it moved up or down until the horizontal line on the target coincides with the crosshair. So then you mark the stake at the bottom of the rod, and then the form can then be fastened to the stake so that its top edge coincides with the mark. So please review that because some construction crews do it differently. So please be familiar with the basics. Benchmarks and deep excavations. So it is easy to establish an elevation at the bottom of a shallow excavation from a benchmark at the ground level. For deeper excavations, however, other methods must be used. So, for example, the angles of depression must be read accurately. And there is a formula for that. So please just familiarize yourself with that because that is important to understand before you even break the ground. So that's for the metric units and for the imperial system. So please take a look at that. And this wraps up our chapter 2. Thank you so much for watching. I will see you in chapter 3. Thank you.